Okay, good morning. I'm going to do the homework problems for this week. In this video, I'm going to try and do number 6 and number 7. And these all have to do with conservation of energy, using gravitational potential energy and kinetic energy. Okay, so number 6 says we've got a mass of 120 kilograms. It's on a platform 5 meters above the ground. If the object is allowed to move down the platform, determine the kinetic energy and the velocity of the object when it's 3.25 meters above the ground. So let's draw a picture. So this is number 6. So we've got an object. We don't know what it is, but it's some kind of object. It's got a mass of 120 kilograms, and it's on a platform that's 5 meters above the ground. And I guess it's going to fall. I don't know. So we're going to start off in a state where we have a height above the ground and we're at rest. Okay. And then we're going to be moving as we fall, and we want to know what our kinetic energy and velocity are at 3.25 meters. So that's, I don't know, halfway point would be here. So I don't know, that's maybe about here roughly, something like that. Okay, so we've just started falling not too long before the point we're interested in. If we assume that this is an isolated system, we're just going to look at the mass and the earth, okay, then we can use conservation of energy. So our initial energies our total of those is going to be the same as our total final energies. Remember, we've got that bucket of mechanical energy that's made up of potential and kinetic at any point. And if we are an isolated system and energy is being conserved, then this mechanical energy value is going to stay the same. Okay. So we know that at the beginning, all our energy is gravitational potential because we're not moving yet. We're just at a height above the earth. Okay. So we're going to have a initial UG, or gravitational potential energy. And then that's going to equal, when we think about this 3.25 meters point, that's going to equal the potential there and the kinetic there. Because at that point, we're still at a height, but we're also moving. So we're going to have some of each of these energies. Okay. So how can we get our initial potential? We're going to use mass times G times H. And then we can do the same thing here. We're just, our H is different, okay, right, for both of those. And that's how we're going to get our kinetic energy. We're going to start with getting that value. So we'll have 120 times 9.8 times 5 equals 120 times 9.8 times 3.25 plus kinetic energy. Okay. And this is just my mass, G, we already know G, and then my two heights, my initial height and then my height that I'm interested in. Okay, so let's see, 120 times 9.8 times 5 gives me 5880 joules. And then 120 times 9.8 times 3.25 gives me 3822 joules. And I'm just going to subtract this number from both sides so I can get a kinetic energy value. And that's going to give me 5880 minus 3822 equals 2058 joules. Okay. Now, how can I get the velocity at this point? Okay, I know that kinetic energy equals 1/2 mv squared. So I'm going to solve this for velocity. I'm going to shift my 1/2 to the other side. I'm going to shift my m to the other side, and then I've got to take the square root of it all in order to solve for velocity. So I'm just taking this equation, I'm just solving it for velocity by itself. And then I can put in the values I have. I've got 2 times the kinetic energy I just figured out, 2058 divided by 120 is my mass. Again, with these type of problems, I'm going to try and do it all at once, but if you're not good with parentheses or you're not sure how the calculator works, then don't do that. And we'll see if I can actually do it without messing something up. I think that's it, 5.86 meters per second. So at the 3.25 meters point, the object has a kinetic energy of 2058 joules, and it's moving at 5.86 meters per second. And it's still got some potential energy because it's at a height above the Earth. Okay, so it's got this potential energy value here. Okay, so that's number 6. Let's look at number 7. So we've got a species of eucalyptus tree, and it grows to high heights. We've got a bird sitting at the top of the tree, and the bird has a nut and it drops it. And the speed of the falling nut at 50 meters above the ground is 42.7 meters per second. So we want to know how tall the tree is. And we want to know if we need to know the mass of the nut in order to solve this. Okay. So let's take a look at number 7. So we've got this tree. We've got a nut falling from the tree. Okay. So our nut is going to start off with all gravitational potential energy, right? And then as it's falling, we're going to pick a point. We're going to say 50 meters above the ground. We're going to have potential and kinetic at this point because we still got a height, but we're moving for sure. We're actually moving at 42.7 meters per second at that point. And we can use conservation of energy again here. Okay, think about this. So our initial potential energy would be equal to our potential plus our kinetic at the point we're interested in, which is our final point. Okay, in this case is the 50 meter point. Okay, so we can get, let's see, what all can we do here? If we put some equations in here, we can answer one of our questions. So we've got mass times g times h for our potentials. We've got 1/2 mass v squared for our kinetic. You can see mass is in all 3 of these expressions. Okay, so mass is going to cancel out. We're not going to end up needing mass. Okay. So then we know, we'll go ahead and fill in everything we know. We know 9.8. We don't know the height of the tree. That's what we're trying to figure out. That equals 9.8 times 50. That's the height of our final point, our point of interest, plus 1/2 times 42.7. That was the velocity they gave us at that point. Meters per second squared. So we'll do a little bit of cleanup here. 9.8 times 50 is 490. And 0.5 for 1/2 times 42.7 squared for kinetic gives me 911.6. And that equals 9.8 times my height of my tree. Let's see, I'm going to add those two together and get 1401. And then I'm going to divide that by, so this is going to be basically 1401.6 equals 9.8 times my height. And then if I divide both sides by 9.8, I can get the height of my tree, which is 143 meters. Okay, so I was able to do all that without needing the mass of the nut because it canceled out of everything. Once I set up my conservation of energy type equation, I'm able to see that really all I need my points of interest, my velocity and my height at those points, which they gave us. I know what G is, I know what 1/2 is, and then I can solve for the height of the tree. So, okay, so that was number 6 and 7 on the homework.